Hey, we're from Group 9 here, going to talk about closed system reversible process and enthalpy. Our group consists of 3 members, Siti Zulaika, Izia, Mezera, and Li Kaiyi. Let's start with the topic of closed systems and reversible process. History of closed system. Sadi Carnot, a French physicist and engineer, made significant contributions to the field of thermodynamics in the early 19th century. System is defined as the space of interest which involve related thermodynamics chemical process, include transfer of matter and energy. Surroundings is defined as the space outside the system. All the matter and energy that are not part of the system but can interact with the system. Boundary is a surface or imaginary line dividing the thermodynamic system from its surroundings. Lastly, universe is all measured space. Closed system is a system that does not allow transfer of matter in or out of the system. Energy in the form of heat or work can cross the boundary, and the volume in a closed system does not have to be fixed. This can be exemplified by a water bottle that has lid or seal will prevent any exchange as it is insulated from the outside. Next is the history of reversible process. The concept of reversibility in thermodynamics can be traced back to the work of French engineer Sadi Carnot. Carnot introduced the idealized thermodynamic cycle known as the Carnot cycle, which consists of 4 reversible processes, 2 adiabatic and 2 isothermal. Scientists like Rudolf Clausius and Lord Kelvin William Thomson made significant contributions to the development of these laws involving the concept of reversible processes. A reversible process is defined as a process in which the system and surroundings can restore to its initial conditions from final state without producing any changes. The extension of spring is one of reversible process because it can reverse back to its original point. Closed system reversible process happens at critical conditions. For example, system must be quasi-static in extremely slow movement. Friction is negligible and no heat or zero entropy during the process. Here is some example of closed system reversible process, such as frictionless motion of solids, slow isothermal compression or expansion of gases, and slow adiabatic compression or expansion of gases. The concept of enthalpy was first introduced by the German physicist and chemist Hermann Helmholtz in the 19th century. Originally, enthalpy was created by Benoit Paul Emile Clapeyron. And Rudolf Clausius, Josiah Willard Gibbs used the concept of enthalpy to describe a heat function for constant pressure. Enthalpy is the sum of the system's internal energy and the product of its pressure and volume. It is denoted by H and is a convenient energy concept defined from properties of a system H equals to U, which is internal energy plus PV, that is pressure, and volume enthalpy is also equals to the heat absorbed or released by the system at constant pressure. Here is some useful equations used to calculate the first law of thermodynamics, quantities in closed system. We always start with the first 3 equations when dealing with closed system reversible process and at some specific conditions. Reversible isochoric, isothermal, and adiabatic processes, equations can be derived based on the theories on conditions. Now, let's try some easy questions to test on your understandings. Pause the video for extra time to attempt. Question solutions are presented here. Question 2, we attempted by using Excel and MATLAB. Any question, just comment below. We are most welcome to discuss here. Thank you for watching this video.